Basics: electronic signals. Electronic signals are represented either by voltage or current. The time-dependent characteristics of voltage or current signals can take a number of forms, including DC, sinusoidal, also known as AC, square wave, linear ramps, and pulse-width modulated signals. Sinusoidal signals are perhaps the most important signal forms, since once the circuit response to sinusoidal signals are known, the result can be generalized to predict how the circuit will respond to a much greater variety of signals using the mathematical tools of Fourier and Laplace transforms. A sinusoidal signal is specified by its amplitude, A, angular frequency, omega, and phase, phi, as Vt equals a sin, omega t plus phi. When working with sinusoidal signals, the mathematical manipulations often involves computing the effects of the circuit on the amplitude and phase of the signal, which can involve cumbersome trigonometric identities. Operations involving sinusoidal functions can be greatly simplified using the mathematical construct of complex domain. See Appendix for more information. The sinusoidal signal from the above equation, when expressed in the complex domain, becomes the complex exponential. Vt equals ae to the power minus j omega t, where the physical response is represented by the real part of this expression. The amplitude and phase of the signal are both described by the complex constant A, where A equals mod of ae to the power minus j phi a.